you need some help on your targets 9 through 11 homework, you have come to the right place. So graphing quadratics, I just want to remind you that we always start with our parent function table, and I'm just going to write it once up here, and then I'm going to do some scrolling when I get to numbers 3 and 4. So our parent function table, and this is coming from your notes on example A, the very first problem we did, and this creates that U-shaped graph, that parent function. So then we create a table for each of the functions we're trying to graph. As a reminder, our horizontal shift, H, is always opposite. So when it says x plus 2, we're actually going to the left 2, which means we're going to do x minus 2. This value out in front, if we have one, is the slope or the vertical multiplier or the vertical stretch. And then this means we're going down 1, so that would affect the y value, which is why I'm putting it after y. And then I'm just going to compare this to the parent function table. So looking at the parent function, these x values, negative 2, negative 1, 0, 1, 2, I'm going to subtract 2 from each of those. And then for the y values, I'm going to multiply each of them by 2 and then subtract 1. So starting with 4 at the top, that would be 7. And then I would get 1, negative 1, 1, 7. And these are the points that we're going to plot for our graph. So negative 4, 7, negative 3, 1, negative 2, negative 1, negative 1, 1, and 0, 7. And there is our graph. So on this one, we're going to start with the domain. So remember, even though this looks like those arrows going left and right are pointing straight up, they're actually going outwards a little bit, so our domain is all real numbers. The very lowest y value on our graph is negative 1, and it goes up from there. And the y-intercept, there's actually a point there this time at 0, 7. Notice it didn't ask for the x-intercepts because they're not at clear, pretty points, and we have not taught you how to solve for those yet, so we didn't ask. Okay, so in number 2, let's talk about the table. So inside parentheses it says x minus 3, which means we're really doing x plus 3. The multiplier out in front this time is 1/2, and then we have minus 2. So going back to that parent function table, we're going to add 3 to each of the x values. And then for the y values, we're going to take half and then subtract 2. So half of 4 is 2, minus 2 is 0. Then we have half of 1, which is a half, minus 2, negative 1.5. Then I would get negative 2, and repeating those y values. So let's plot these points. 1, 0. And we're just going to do the best we can with those decimal values. Okay. Ooh, missed it there. You get the point. All right, our domain. So how far left and right? Hopefully you're noticing a pattern by now. Forever, so we say all real numbers. And you can write out all real numbers if you want. I'm just lazy and I like to use the symbol. The lowest y value on our graph is negative 2, and it goes up from there. So y is greater than or equal to negative 2. The x-intercepts we can see on our graph are 1, 0. Make sure you write it as a point, and 5, 0. And our y-intercept, this is where my graph got wonky, but it's somewhere in that region. I just can't tell exactly where. So this is where I'm going to actually solve like we did on our notes. And I'm going to solve by plugging in 0 for y in our original equation. So calculating this, negative 3 squared is 9. Half of that would be 4.5. And then that would give me 2.5. So 0, 2.5. So again, my graph got really wonky here. We could actually correct it now that we know that the y-intercept is at 2.5. Make that look a little bit better. Almost looks worse, but make sure that point's on there. So it's just more of the same down here. we're going to make our table. And again, that parent function up there, that's what I'm always comparing it to. So even if I don't keep scrolling up and down, just know that's where I'm looking. So inside parentheses is x plus 4. So we are not going to do x plus 4. We're going to do x minus 4. There's a negative out in front, so that's going to be a negative multiplier on y, and then minus 1. So subtracting 4 from each of the x values. Negative 2 minus 4 is negative 6. Then we get negative 5 and continuing down. And then I'm going to make each of the y values negative and then subtract 1. So starting with 4, negative 4 minus 1 is negative 5. Negative 1 minus 1 is negative 2. And then that would be negative 1, negative 2, negative 5. And these are the points I'm going to plot. Domain, all real numbers. The range, this time the very highest y value is 1 and it goes under 1, so y is less than or equal to 1. And the y-intercept, again, I'm going to have to solve for this because I can't see what the y-intercept is just by looking at my graph. So going back to my original equation, I'm going to plug in 0 for x. And I'm going to calculate that. You could throw it right in your calculator. That gives me negative 16 minus 1, which is negative 17. So 0, negative 17. And that's believable based on the graph. It would cross way below what I have graphed here. Now taking a look at number 4. So our table, so this is, again, it's meant to be an easy one, but I actually think it's tricky. I think it's easier if you rewrite it like that. So we can see that x doesn't have anything that's happening to it. Y is having minus 8. So just copying down the x values from the parent function and then subtracting 8 from each of the y values in the parent function. And that would be negative 7. And then I'm going to graph these points. Negative 2, negative 4, negative 1, negative 7. There we go. Now on this particular one, it doesn't ask for our x-intercepts because our graph will have x-intercepts, but we can't tell where they are. We don't have any of our pretty points, as I like to call them. So the domain is all real numbers. The range is y is greater than or equal to negative 8. And the y-intercept we can actually see on the graph this time is 0, negative 8. Flipping it over to the back of your homework, writing the equation. So we always go back to that general form, y equals m times x minus h squared plus v. When we look at a graph, h and v are pretty easy to spot. Just find your vertex. So that vertex is at 3, 2, 3, 2. M is a little bit more difficult to find. So to find m, we're going to actually plug in the 3 and the 2 to that general formula that I wrote above. So that'd be x. Make sure you do minus 3 because you're flipping the sign. And then pick a point on your graph. So I'm going to pick this point right here, which is 4, 5. And plug in the 4 for x and the 5 for y. And then you're just going to simplify and solve. So inside parentheses, if I combine those terms, I get 1. 1 squared is just 1. 1 times m is just m. And if I subtract 2, I get m is 3. So now I have all 3 pieces of information to write the vertex form. Y equals 3, parenthesis, flip the sign, x minus 3 squared plus 2. Same process, new problem. We're going to look for h, v, and m. Starting with the vertex is at 0, negative 9. Then for our m value, we are going to find another point. I'm liking the look of 3, 0, x and y. So this time, I kind of skipped a step here. Let's go ahead and just put h and v. So that would be x minus 0 squared minus 9. And then let's plug in our x and y value that I picked. So 0 equals m, 3 minus 0 squared minus 9. Simplify. 3 minus 0 is 3, squared is 9. If I add 9 to both sides and divide by 1. So we get m is 1. So we have y equals 1, and we don't even have to write that, times x plus 0 squared minus 9. You could also just write y equals x squared minus 9, and that would be fine as well. That's your homework for targets 9 through 11.